The senior design class of 2016 were tasked with designing and building a 3D printer that would outperform the industry standard printer in the areas of resolution, repeatability, accuracy, and precision. Since the purpose was to create a printer capable of high-resolution, precision prints, a design was needed that was very stable in order to reduce vibrations and shaking during operation. The team decided on a kinematically stable tetrahedron frame to base their design around. The tetrahedron is a three-sided pyramid and is by design very geometrically stable, reducing resonant vibrations. To further reduce vibrations, the steel tubing frame was filled with vibration-dampening epoxy resin used for dampening machine tooling. Along with reducing resonant vibrations, the large mass of the epoxy-filled frame structure will decrease the effect of outside forces on the printer. Once the frame was decided on, the team had to decide what kind of printer style they wanted to use. They decided to use a Delta configuration printer style because they're known for precision and stability, and the Delta layout would fit well within the tetrahedron frame design, with the frame providing direct structural support of all critical components and a safe enclosure from any outside interference. So the team set to work and delivered the Tetraprint 3D printer prototype in May 2016, but were unable to get it operational due to time constraints. Then, in fall 2016, the 2017 senior design class was tasked with picking up where the previous team left off, which entailed getting the printer operational, optimizing the print quality, and testing it against the leading industry printer. When we, the senior design class of 2017, took the project over, we had very little instruction or documentation as to how the printer was built and intended to be used. Consequently, much of our time has been spent trying to make sense of what had been done, right, wrong, or indifferent. From there, we had to find what kind of firmware was needed and how to use it. Once communication was established between the Rambo motherboard and the printer, we went through the operation of each printer component one by one and determined why they were not operational. The major problems we ran into were improper wiring, faulty components, improper computer code, faulty computer code, communication issues, and calibration. Pinpointing exactly where the problems lay proved to be very time-consuming. Despite all the issues, we did succeed in getting the printer fully functional. However, after hundreds of attempts, we were unable to achieve an accurate enough calibration to attempt a viable print. As time ran short, and only a few weeks remained, we shifted our focus from getting the printer working to providing good documentation of what, how, and why we did what we did, and what the outcomes were of our actions. This is for the purpose of continuity, so whoever picks up this project after us has a roadmap to pick up and run right where we left off.